So we have to diagnose. You are in the first year. Remember these steps from sample collection to microscopy, because from second year, third year onwards, we are not going to use first these two sample collection transport, because you should know it. It's very important to find a pathogen, to diagnose a pathogen in the laboratory. These steps should be followed. First, sample collection. There should be a proper sample collection. There should be a proper sample collection. There should be a proper transport of the sample. And then should be the other things like culture, microscopic observation, serology, blah, blah, blah. Okay? What is a sample collection?
From bacteria.
Sample collection, you need urine, you need a blood, you need an exudate. Section. Yes. For example, you have a patient of a urinary tract infection. You cannot take a sample from his mouth, okay? You need what? Urine. Proper sample collection. And collection in a proper way. Because if sample is not taken properly, you can get the wrong results. False positive, okay? Even sometimes false negative. And transport. Once you collect the sample from a patient, either from the ward or from the, if he is in the, it comes for the hospital for the checkup, and the doctor recommends some tests at that time, some microbiological tests. At that time when sample is taken, it should be taken properly to the laboratory. So transport is very important, because some microorganisms die immediately. When they are taken out, they may die within 2-3 minutes, finish. So for that you need a transport media. You are, after the lab will finish, you will go to your home by means of car, okay? Some will go by walking. So there is a means of transport. Similarly, when you collect the sample, there should be the transport. So what is the transport? We will see now. What are the things we can carry the bacteria? Not for all, but for some of them, okay? Some of you need a proper transport, means of transport. Then microscopy, you know microscopes are here. You can see under the microscope whether bacteria is gram positive, whether it is gram negative, whether it is a cocci, whether it is a chain shaped, where they are in the clusters. So microscope gives you the two things, either after the gram stent, you will say it is a gram positive or gram negative. Then with the help of microscope you can see. Gram stent is a different the technique which you do, but it has its own steps. 1, 2, 3, 4. After finishing, then you can see under the microscope whether it's a gram positive or gram negative. Also under the microscope you will see whether it is a cocci, whether it is a rod, in chain, and in clusters. All you can see this under the microscope. So this is called the microscopy, because different microorganisms are different shapes. Some are cocci, some are round, some are diplococci, two cocci together, some are in clusters, some are in chains. Then one more step of identification. Microscope is the first step of identification. Second identification step is a culture media. You need a food, like we eat the food for our survival, microbes also need the food for the living, okay? So this is called, this plate is this cover and this is the bottom. It's called culture plate. What is inside here? Food. But in microbiology term, we call it as culture media. We call it as a culture media, because you have a sample of urine, or even for the pus or something, you put it sample here. Media, you know, it can be a McConkey, it can be a blood agar, it can be a neutron agar, or other type of agar. So, why agar is here?
Growth of the bacteria.
Agar is a solidifying agent. Okay? If agar is not present here, it will not sit here. It will not solidify. You know, it cannot fall down. If agar is not present, the media will fall down. So agar is a just simple. It solidifies the media. It holds the media. actual media is present here. It contains, the media contains glucose, proteins, necessary vitamins required for the microbe. Okay? So agar is a solidifying agent. Along with the agar, there is a components. There are components like glucose. If we put without agar, if we put the cultured media here without agar, it will not stick like this. Because on agar, the job of agar is only to provide this, to make this media solidified. It does not help microbe to grow. Agar does not help microbe to, only the nutrients here they help, but why we put agar? To make this solidified. If we do not need agar, at that time we keep the media in a bottle in a liquid form. It is called a liquid broth. It is called a liquid broth. But if we need to solidify, that is important to add the agar. Agar is not a nutritional factor. Yes, correct. It is not a nutritional factor. And we do the biochemicals. In the biochemicals, we can see whether some bacteria prefer glucose as a source of energy. Some prefer lactose. Some prefer sucrose. Some prefer mannitol. So this is God's nature, that microbes have a ability to ferment different kind of sugars. In terms of microbiology, we use the term fermentation. We use the term? Do not forget these points. In microbiology, we use the term, what is the fermentation? Fermentation means breakdown of sugar. Breakdown of sugar. Breakdown of sugar. Sugar can be glucose, lactose, very good, fructose, and also mannitol. Mainly we are using these type of sugars. So in a microbiology term, we call it as a fermentation. So, and for sugar fermentation. And second, the biochemists, some microorganisms produce enzymes. Enzymes. These are called the enzymatic tests. These are called masala, catalase, tryptophanase. You have heard the name of an amino acid. What is a tryptophan? Tryptophan is an amino acid. Some bacteria break down tryptophan with the help of enzyme tryptophanase. So tryptophanase enzyme is present in bacteria. Come in. Okay? And oxidase, one more enzyme in the bacteria. Okay? Coagulase, one more enzyme. This is not necessary. All the three are present in the one microbe. Okay? Some microbes have coagulase enzyme. Some microbes have catalase enzyme. Some microbes have this tryptophanase. Some have oxidase. So it is not important. It depends upon the pathogenic bacteria, which type of enzyme is present. Similarly, it is not necessary that all bacteria can use the sugar. No, they can use different type of sugars. Different type of sugars. And one more point is called antibiotic sensitivity. And what is antibiotic sensitivity? First, what is antibiotic? Okay. Which kill the microbe. Antibiotic, we have seen in our families when we have some patient in our family, we went to doctor prescribing the antibiotic. The purpose of antibiotic is to either kill or stop. Either kill or stop the growth of pathogenic bacteria. One test, it is called antibiotic sensitivity. We do the test in the laboratory on a it's agar called
antibiotics.
What?
Tried antibiotics on it.
We do one thing, we prepare a media and we put antibiotics here. Antibiotics are circle in shape. I can show you now. And like this, inside we put the antibiotics here. Then we put first we put a culture of a bacteria, for example, E. coli or Staph aureus we put here, and we put 5-10 antibiotics. After 24 hours we see which antibiotic kills microbe, which do not. If antibiotic is sensitivity, it will not allow the bacteria to grow. Okay, it will fall in the clear zone. If antibiotic is not effective against the microbe, the microbe grow and it will not show any kind of effect. Give me a moment, I will bring the one antibiotic disc from here. These are called the antibiotic discs. These are called the antibiotic. You have to remove this lid. Okay, this is penicillin antibiotic. Okay, what you do in the way when you have to do the doctor wrote. Masalan patient person A, he is having the urinary tract infection. Doctor wrote antibiotic sensitivity test, and when the patient sends his sample to the laboratory, in the laboratory they culture. Okay, they found the microbes. They put the microbe here after the growth, and finally they bring various type of. You see here antibiotic, number of antibiotics here. This is penicillin. This is nitrofuran antibiotic. This is vancomycin. So from each of them from one, and he remove it and put here. Okay. The next morning he sees the result. If around this antibiotic disc, one I should take out from here.
Victor,
Yes.
how much does it take to show the results of this?
Yes, go ahead. Yes.
Yes, how much does it take to show the results?
All pathogenic microorganisms usually the pathogenic microorganisms grow within 24 hours. Remember this point. It's a very good question. Usually within 24 hours but some microorganisms need days, 4 days, 5 days, 6 days. Okay? One of the example, always remember, you have heard the name of bacteria, Microbacterium tuberculosis? Correct. That causes the TB, a chest disease. If you grow that microbe in a laboratory, it takes 7 days minimum to grow. But like E. coli, like staph, like other microbes, it needs only 24 days. So what we do, I am taking by this way, but this is not a proper way to collect. This is the antibiotic disc. It contains antibiotic. So what we do, one by one, we put the antibiotic discs here. First, you are suspecting the bacteria Staph aureus, you put Staph aureus here, okay? Then you put various type of, you put penicillin, vancomycin, one by one, and you put it here. But with a proper procedure, not by hand. And similarly, 1, 2, 3, 4, 5, 6, and you keep it under incubation in the incubator for 24 hours. Next morning, either 12 hours or 24 or next morning when you come out, when you see this, if antibiotic is sensitive, there will be clear zone, there will be no growth at all, it will not allow microorganism to grow. If it is resistant, there will be the growth of microbe, okay? So this is called the antibiotic test.
This I got for holding. This there is. Inshallah.
So antibiotic test is one more way to detect the microorganism, and one more is called the serology. When we have a blood, when we centrifuge the blood, what's remaining at the bottom? On the top is the serum, at the bottom it will be RBC syrup. What serum contains?
Fibrogene.
So what's present in the serum?
White blood cells. White blood cells. Platelets. White blood cells. Fibrogene.
Talk about the serology, it contains the antibodies. Contain that. So this is one more test. If somebody is having an infection, For example, E. coli infection, his body produces the antibodies against it, okay? So we can use the antigen-antibody test to confirm whether this person is having a disease or not. This is serology, antigen-antibody reaction. And last is the PCR. PCR is a molecular method. You isolate you are suspecting a person is having an infection of the microbe. You try to find his DNA by using the method PCR, polymerase chain reaction. So let us see now. Sample collection, as I told you, it's important you use the aseptic methods to collect the sample. You need the gloves, you need the needle for the sample collection. Then what could be a sample? Sample could be a blood, it could be a cerebrospinal fluid, it can be a urine, it can be a wound swab, exudates from the lesions. During sample collection, always avoid the contamination of normal flora. Transport the sample immediately to laboratory. If you are thinking that the sample will be processed after 3-4 hours or maybe on the next day, then we can use the transport media like Strott's media, MI's media and Carey-Blair media. All media they are called transport media. You can store the bacteria in a normal saline media for a longer period of time. And this is the picture. Okay? Nasal swab. You see the bird, it's having the cotton. And this why we can use it for sputum or for the urine. For Carey-Blair transport medium for rectal swabs, okay? ME's transport media for throat, wound infections, for vaginal discharge, other things. And for Strott's media for streptococci like bacteria. Blood samples, we carry two type of blood bottles. You see, one for aerobic bacteria, another for anaerobic bacteria.
Which one for the green one?
Green one for aerobic and yellow one for anaerobic. Clear? So now come to the microscopy. In the microscope you can do the first, if you have urine, you centrifuge it and you collect the sediment and check under the microscope to see the cells or bacteria is present or not after staining. Second is a direct gram stain. What's a gram stain? It is a stain.
Differentiate.
What it contains this stain mainly?
Color.
What are the steps in the gram stain?
Steps to make the test.
Yes.
First you take
We use
this heat. And you put the
What kind of chemicals we need in the gram stain?
What?
But what we need in the steps?
We need alcohol swab.
We use four.
What?
Alcohol.
The first step what?
We put it in the bacteria. Use base,
The gram stain contains four things. Crystal violet. In the first step, crystal violet. Then you need iodine. You need also alcohol or a water. And last you need safranin. Safranin is a dye which differentiates between gram positive and gram negative. Gram stain is a technique. First direct gram stain, it differentiates between gram positive and gram negative bacteria. We do the gram stain in steps. In the first step we add crystal violet for 1 minute. Then we wash it with the water. Then we add the iodine. What's the role of iodine? You didn't have a lab on the gram stain before that?
No.
Take it, but before
But why? Then why you do not remember?
it takes
these
in the
things?
first week.
Crystal violet is a dye. It is retained by the cell wall. Iodine is a mordant. Mordant. It acts as a mordant. What's the role of iodine in the gram stain? I am asking you. You had this lab earlier. When you add the crystal violet, now tell me what is the difference between gram positive and gram negative?
Red and purple. Someone.
No, leave red and purple. What is the structure of gram positive and gram negative bacteria?
Acid.
Diplococci.
pick up and
خليني أتذكر.
قاعد أصفر رجعت لألمانيا.
What is the difference between gram positive and gram negative?
ذاك diploid cocci.
positive it will be thicker.
Positive container between left and thicker.
The difference on the bacteria or on
Tico acid, yes.
the stain, the
Tico.
same stain.
First you should know what is gram positive and gram negative bacteria cell wall. Then you can talk about the staining. So quickly, time is running out.
Okay. Tico acid.
In gram positive bacteria, the main thing that absorbs the crystal violet stain is peptidoglycan. Peptidoglycan is present in gram positive bacteria. Peptidoglycan.
It's thick.
And also there is presence of cacoic acid in gram positive. But when we talk about the staining of crystal violet, crystal peptidoglycan takes up the stain. And what is in the gram negative?
It will be thinner.
Lipopolysaccharide layer in the gram negative. So what happens actually when you add when you do the gram staining? Listen to me carefully. When you add the crystal violet, it's taken up by both the cell walls. It's taken up by both the cell walls. Then in next step you add the iodine. When you add the iodine increases. It acts as a mordant. It increases the time and it helps this dye crystal violet to interact with the cell wall. Okay, it helps. So when you add the crystal violet, gram positive peptidoglycan takes up the crystal violet. Gram negative cell wall also takes up the crystal violet with the help of the iodine. It acts as a mordant. Then you make one more washing. You make one more washing with the alcohol. When you do the washing, washing removes excess of crystal violet from peptidoglycan and lipopolysaccharide layer. But the gram positive bacteria having the peptidoglycan, it retains some of the stain. It retains the crystal violet inside. And lipopolysaccharide, gram negative, it releases all. The last step, when you add the safranine, what happens now? Gram positive look like purple, correct. Gram negative look like
Red.
You know why?
Pink.
You know why? Safranine is a pinkish in color, okay? As I told you, the peptidoglycan retains some of the crystal violet. When crystal violet dye is there and safranine, it gives purple color. But in gram negative, there is no crystal violet. There is only safranine. It looks like the pink. This is the gram staining, okay? Remember, do not forget this. So gram staining, name of the scientist, academician, his name was Graham. He applied these steps and to differentiate between gram positive and gram negative bacteria. So this is the gram stain. And second it is acid fast stain. What is the acid fast stain? Why acid fast stain is needed? What is you told me that you know about the tuberculosis bacteria, microbacterium. What about the cell wall of tuberculosis bacteria, microbacterium tuberculosis? What is the special feature of tuberculosis bacteria? In the tuberculosis bacteria, there is no peptidoglycan. There may be present, but there is no lipopolysaccharide. But important thing is in tuberculosis, Microbacterium tuberculosis. It is the name of a bacteria, Microbacterium tuberculosis. There is presence of outer covering of fatty acids. Outer covering of fatty acids. Do not forget this for your whole life. In the tuberculosis bacteria, it has an outer covering of fatty acids. Outer covering of? And this fatty acid is a special fatty acid. It is called mycolic acid. It is called mycolic acid is not present in gram positive and gram negative bacteria. Remember this in your mind. In gram positive and gram negative bacteria, there is no mycolic acid. One bacteria, Microbacterium tuberculosis, it has its outer covering, it's called as mycolic acid, made up of fats, fatty layer present on the surface, outer surface of the bacteria. It makes the bacteria very special. And